Now we're going to look at how to use derivatives to find extreme values of a function in an interval. So in this case, we have a function f at x, and we're looking at the interval a and b. So we want to find extreme or high and low values in that interval. Well, the max and min points that are local or higher than lower than all the points around them will always have a tangent slope of 0, which would mean the derivative would equal 0. But what you have to be careful for is that if I cut it at a and b and I want to know the max and min value, the value down here is actually lower than this local minimum. And same thing, the value associated with b actually is higher than the local maximum. So using f prime equal to 0 will get you these little relative or local max and min, but you have to be careful about the endpoints, especially if the function does go on forever. So the steps are to find extreme values for a function f at x on an interval. A is less than x is less than b, so a is going to be between two numbers, a and b. You're going to solve f prime equal to 0. So you're going to look for all the points that have horizontal tangents, but you're just going to take any answers that are within that a and b. So you're going to solve equal to 0, then you're going to compare your answers to the interval, and you're going to throw out any that aren't in the interval because they're not relevant to what we're doing. Then step number 2 is to take those x's that you found in the interval and your two endpoints and sub them into f and x to find the max and min values. So if we look at some examples, example number 1, find extreme values for f at x equal to x cubed minus 6x minus 4 when negative 1 is less than or equal to x is less than or equal to 7. So this is our interval and this is our function. So step 1 is to find the derivative, which is going to be 3x squared minus 6. So I just took the derivative of that, and this has nothing to do with related rates anymore. Now we're just doing normal derivatives because we're working with functions with x, but we're going to look for all the points where that equals 0. I think I wrote this question down wrong. The original question, sorry, it's supposed to be x cubed minus 6x squared minus 4, which will give us a derivative of 3x squared minus 6x. Sorry about that, so make sure you add a square to the x there. In order to solve this, I'm going to common factor out a 3x, and then I'm going to find my 0. So x equal to 0, because 3 times 0 is 0, or x equal to 2. And I'm going to take both of these and compare back to my intervals. So 0 is in the interval, 2 is also in the interval. So I have to use all of these. And I have to use my endpoints. So what I'm really going to do is I'm going to find f at negative 1, because that's my endpoint, f at 0, because that's one of my possible extreme values, f at 2, and then f at 7. And here's where you have to be careful. I'm maximizing the original function. So when I sub in negative 1, 0, 2, and 7, I'm not going into the derivative. I'm going into the original function. So f at negative 1, I'm just going to do negative 1 cubed, which is going to be negative 1, minus 6 times negative 1 squared, minus 4. So that's going to give me negative 11. F at 0 is going to give me 0 cubed, minus 6 times 0, minus 4, which is going to give me negative 4. F at 2 is going to give me 2 cubed, which is 8, minus 6 times 2 squared, minus 4, gives me negative 20. So 8 minus 24 minus 4, yep. And f at 7 is going to give me 7 cubed minus 6 times 7 squared minus 4. I'm just punching into my calculator. Gives me 45. So now what I've done there is find all the values associated with my potential local max and mins in my endpoint. And to find the extreme values, extreme is code for max and min. So I can look at this and say the max value is 45 at x equal to 7, and the min value is negative 20 at x equals 2. So my max ended up being one of my endpoints, and my min ended up being one of my points in the middle. But those are the extreme values for that function. So number 2, find the maximum values of negative 4x squared plus 12x plus 7, first on the interval 0 to 4, and then second on the interval 2 to 9 over 2. So the good thing is that it's really the same question when I'm looking for f prime, which is going to give me negative 8x plus 12. I'm going to solve that equal to 0. I'm going to take out a negative 4 and get 2x minus 3. So x is 3 over 2 is my possible 0. 3 over 2 is, I can think about it as 1.5. I'm going to leave it as 3 over 2, but 3 over 2 is definitely within the interval 0 to 4. So I'm going to find f at 0, f at 3 over 2, and f at 4. I take my possible local max or min, and I need to compare it to my endpoints. I'm careful that when I sub in, I skip over the derivative and go back to the original function. So f at 0 is going to be 7. I'm going to skip down and do f at 4 now because it's a little bit easier. So negative 4 times 4 squared plus 12 times 4 plus 7, negative 9. 3 over 2, I mean, I guess you could use 1.5. I'm actually going to use it as an opportunity to practice working with our fractions. So I get negative 4 times 3 over 2 squared plus 12 times 3 over 2 plus 7. So this is going to give me negative 4 times 9 over 4. To square a fraction, you just square top and bottom. Plus 12 times 3 divided by 2 is going to be 18. 12 times 3 is 36 divided by 2. Or you can do 12 divided by 2 to get 6. Times 3 is 18 plus 7. So this is going to give me, the 4's will cancel out here. Negative 9 plus 18 plus 7 is going to give me 16. So the fraction wasn't really that bad to deal with at all. And then, so on this interval, my max is 16 at x equals 3 over 2. Min is negative 9 at x equals 4. For b, I'm going to repeat the process. My derivative would still be the same. So I get x as possible 3 over 2. Well, 3 over 2 is 1.5. It's not in this interval. So I'm just going to skip over it and not even use it. And for b, I'm just going to test my endpoints. Because there's no point redoing the derivative and solving it equal to 0. I'll get the same answer. And because this number is not in my interval, I ignore it. If there was more than one number, I might ignore both of them. I might only grab one of them. It all depends on whether or not they lie within that interval. So f at 2 is going to be negative 4 times 2 squared plus 12 times 2 plus 7, 15. 9 over 2, again, I'm going to take it as an opportunity to practice my fractions. So I get negative 4 times 36 over 4 plus 54 plus 7. I did 12 times 9 divided by 2, or 12 divided by 2, which is 6 times 9. The 4's will cancel out. I'll get negative 36 plus 54 plus 7. Just make sure I get the right answer. 25. So therefore, for this interval, the max is 25 at x equals 9 over 2. Min is 15 at x equal 2. So find the derivative, solve it equal to 0, take the points within your interval and your interval endpoints, sub them all in, and then for the extreme values, you're looking for the highest and the lowest.